Hello guys, welcome back to the question. So today we will solve a question from the chapter integral functions and let us see what does our question say. So we have to integrate a given function that is root of 10x divided by sin x cos x. So we can say that we can observe that the question is not straightforward. We have to make some changes in the given expression so that we can convert it into the integrable form. So what are the changes that we need to make? As far as I think that since we are given 10x here, we somehow need to make cos sec square x, as we all very well know that the differentiation of 10x with respect to x is sec square x. I hope you all remember that formula. So we have to somehow make our expression as sec square x in the numerator or denominator, anywhere, whichever is feasible. So we can see that we already have one cos x here. So if we multiply in the denominator by cos x and in the numerator by cos x, we get cos square x in the denominator or sec square x in the numerator. So that may be our idea. That should be our first approach. So now let us see the first step. Yeah. So they are doing the same thing. They are trying to multiply the numerator and the denominator by cos x. So what do they get? They get root 10x into cos x that we just multiplied upon sin x cos x, that was our original denominator, and we are multiplying cos x to it. So what do we get now? We get root of 10x upon 10x cos square x. This is the final integrand that we get. Now moving to the next slide. This part is further simplified to this thing. Now you can very well see that we have sec square x and 10x together. So the question has become easy now. We have now finally got into the position where we can integrate this integrand very easily. So what do we do now? We assume 10x as t. So now differentiating on the both sides, on this assumption, we get sec square x dx is equal to dt. Now we make the proper assumption, proper substitutions, that is sec square dx is dt and root of 10x is root t. So we get our final integrand as dt upon root t. Now this is a pretty straightforward integral. I hope you can all solve this. So we get our final answer as 2 root t plus c. But before signing off with the final answer, we need to remember that t needs to be back substituted to the original variables that were x. We assumed something that 10x is equal to t. So t is equal to tan inverse x. So now we need to replace it here. So now let us see the last step. We get 2 into root 10x plus c. I think I made a mistake. Yeah, this was a mistake. T is equal to 10x. I just made a mistake here. Let me erase it for you. We directly substitute t is equal to 10x. So we get our final answer as 2 into root of 10x plus c, where c is an arbitrary constant. So that is it. I hope you all got it. Have a nice day.